And always open your user's manual, read through the procedure, and then proceed. So the shutdown procedure in the user's manual is going to be first fail AC input. When we do this, the system's going to go into alarm. We'll silence that. It's running on battery power now because we've obviously failed AC. So step 1, fail AC input. Step 2, turn off the installation key switch. Step 3, turn off the battery breaker, or open the battery breaker. And then if our load is on, we'll turn our load off. If necessary, if we're going to work on batteries, we can come down here and open all our battery fuse blocks. And then of course turn off the feed power to the inverter itself. Remember, the system is shut down but not safe. We still have batteries maintaining the voltage. We have AC and DC caps maintaining the voltage. So shut down but not void of voltage. Startup procedure. First thing we're going to do is verify everything is in the off position that it should be in. All of our input, output, and battery breakers are off. Our key switch is off. If our fuses are open, we'll go ahead and close them now at this time. So step 1, we're going to close our main DC breaker, followed by our main input breaker from the panel, and then our local input circuit breaker. And then our key installation switch we will now turn on. You'll hear a slight hum come from the inverter. The display will be lit and the system should be functioning properly at this time. If there are any alarms, we got to address them, obviously. If the system comes up an alarm, identify the alarm, write it down, and then call service center or manufacturer and report it. So that's it. We got our system successfully on. We can then turn our load on as well, and that's a startup and shutdown procedure. So that seemed pretty good. Is a warranty policy sheet for the batteries in particular. There are some requirements on that sheet. One is cell temperatures. We can't have any individual cell temperature exceed 93 degrees Fahrenheit for more than 30 days, or 92 degrees Fahrenheit for more than 30 days annually. The only reason we should have that is if we have an actual failure in the battery itself, or we're extremely discharging and recharging the batteries repeatedly. That shouldn't happen 30 days a year. So typically it's because there's a failure in one of the batteries. So that's condition 1. Condition 2 is ambient room temperature should not exceed 77 degrees Fahrenheit. Battery life expectancy goes down dramatically when you raise ambient temperature. When you're at like 90, 91 degrees Fahrenheit, you get half the expected life of the battery. So it has a dramatic effect on the battery, not to mention you're more prone for a catastrophic failure in high temperatures, at least in my experience you are. So outside of that, the other conditions, which there's 3 points on that one sheet that specify maintenance. We need to do maintenance in accordance with all literature included with the system, and we have to document that maintenance, which means not just write down the date and time at which we did the maintenance, but we have to have actual readings. So the individual doing the maintenance needs to come in, for example, record the total volts DC and the charge current, if any at the time, as well as all individual batteries, write all that information down. Then we need to load test the batteries. One way of doing it would be to fail AC input with as much load applied as possible when not critical. So if the system were to fail, we don't put someone in a bad spot because the lights are no longer on. So we perform that test and then we let the system run for a given amount of time, and that's dependent on how much load is on the system. Generally 50% or less, we're going to let it run anywhere from 20 to 30 minutes. 50% or more, 15 to 25 minutes. So assess that information once you know your load. So we effectively discharge the batteries. We then write our total volts DC down again. And this time we take all of our current from each battery. Let me change, not each battery, each string. So we're going to have 3 current readings. We have 3 strings of batteries. We need to get the current reading from this string, and this string, as well as all of the individual battery voltages. The current reading from each string is important because we have a series parallel circuit. The total voltage of this battery, and this battery, and this battery, remember I'm talking about the entire string when I say battery, the total voltage can't differ because they're all bonded at this point, positive and negative, so they're the same, right? If we have a failure here and this battery wants to drop its voltage under load, let's say when you load it down it goes down to like 11.5 volts. It can't do that. Physics, obviously, it can't differ because our total volts for the 3 strings has to be the same. So what we're going to see is it won't support load. So if we see 10 amps of discharge here, 2 amps of discharge here, and 10 amps of discharge here, we know we have a problem in this string because it's not supporting the load that it should. You know, even if we don't see anything voltage-wise, there is an issue there. So this is a current, discharge current is a strong indicator of a failure or a potential failure. And then of course voltages are also an indicator of that, and the individual taking the voltage reading should know what he's looking at. You know, generally you're looking for consistency. Float voltage or full charge is going to be in the neighborhood of 13.5 volts. Discharge, typically when you discharge them, you're not bringing them much below 12.2 or 12.3 in that neighborhood. And again, you're looking for consistency. You know, if I got 12.5, 12.5, 11.8, 12.5, I have a problem here. You know, so there's a lot of information because we have 3 parallel strings of batteries, and we have to properly assess that information to identify a failure. The other thing for maintenance, the one thing I didn't mention is the fan. There is a fan in this system. It's located here and it blows across the heat sink. That fan will come off and on based on temperature, but when the system runs on battery power, the fan is always on. So that's the time to identify that the fan is functioning properly. In particular, if you're calling the manufacturer or service center to report an issue or for any reason, they're going to want your serial number to identify the particular unit. So that's all that information there. Also on the top of the electronics cabinet cover is a number to call service. That's direct number for the manufacturer. Someone can be reached 24 hours a day. You're going to get a phone service, but someone will call you back anyway.